Welcome to Train Signal. You are watching Custom Recovery Plans. In this lesson on custom recovery plans, we will review recovery plan steps and how you can customize them. We will explore custom recovery options for virtual machines. We will reconfigure the network settings for recovered machines at the recovery site, including VMware methods for individual virtual machines, as well as for groups of virtual machines. We'll also cover non-VMware methods for reconfiguring the network. Finally, we'll discuss options to avoid custom network configuration altogether. And without further delay, let's get right into this lesson. A recovery plan completes a prescribed set of steps in a specific order. You can't really change the order of the default recovery plan steps because certain activities have to happen in a certain order, otherwise SRM doesn't work. A good example of this is that replicated data stores need to have snapshots created and then presented to the recovery site ESX servers before an SRM test can begin. Without this step, there are no virtual machines to test the recovery of, and therefore SRM won't work properly. But although there is a rigid set of must-have steps in a specific order, there are also still options to create a very flexible recovery plan. SRM allows us to insert commands before and after the base recovery plan steps. We'll explore options for these commands in more detail when we demonstrate custom VM recovery. These commands can be anything you can run from the operating system of the SRM recovery site server. Batch file, Perl script, VB script, but most popular moving forward will probably be the PowerShell script because of its high-level nature and it's easy to write or get a lot done with fewer code. We can also insert messages before and after steps to notify recovery site admins of key steps to complete or other actions to take. Think of a message as a pause in the SRM workflow with an accompanying message or instruction. A key feature of the recovery plan is that the virtual machines can be grouped by the priority in which they should be recovered. There are 4 priorities that a virtual machine can be: high, normal, low, and a no boot priority, or a virtual machine that doesn't boot up. The high priority virtual machines are booted first in a serial fashion. That is, one after another, with the second virtual machine not being able to boot until the first machine has completely booted up and its OS heartbeat has been restored. The OS heartbeat is what you'll get with VMware Tools, and once VMware Tools is up and running, the heartbeat is then restored so that the next virtual machine can go. The next group of virtual machines would be the normal group. I have it listed with low priority because they behave quite the same way, in that the normal virtual machines will not boot up until the last group has completely booted. But with both normal and low priority virtual machines, they'll boot up in a serial fashion per ESX server. So if you have multiple ESX servers, although you can only do one at a time on each ESX server, you'll be able to boot up multiple virtual machines on across your infrastructure, so 1 per ESX server. This can help speed up the recovery of the SRM recovery plan. So once the normal virtual machines have all been booted up, the low priority virtual machines would then kick off after the very last normal priority virtual machine has booted and its operating system heartbeat has been established. And then finally, the no boot VMs would be recovered, but obviously not booted up. Item of note here is that you really don't want to make too many virtual machines as a member of the high priority group. It will slow the time to finish the recovery greatly. And instead, it's a good idea to keep the bulk of your virtual machines in that normal or low priority group so that you can have multiple virtual machines booting up at the same time. Also, a key point to consider is that failovers, or the actual full recovery plan, has a different set of steps than a test recovery plan would normally have. but there's also some common steps that make up the core to both recovery options. I have this detailed in a table within the following slide, which I'll show you now. So we have three groups here. We have the both, which would mean both recovery plans. Then we have the test recovery plan column in the middle. Then we have the recovery only, so this would be the full failover. And we'll start with both because these are the steps that are done no matter which recovery plan we choose. The first step is initiate storage operations, so this would be taking and preparing the replicated storage and presenting it to the ESX servers. The second step is unregistering placeholder VMs and registering the recovered virtual machines. The third step is optional, and that is suspending local virtual machines that might have been used for test and dev to get some use out of that disaster recovery hardware. Those will be suspended at the recovery site to make room for the recovered virtual machines. Then we get into the priority groups. So we'll recover high priority virtual machines first, followed by normal, followed by low priority. Finally, we'll recover the no power on virtual machines or the no boot virtual machines. So in a test recovery, we've basically started with the steps we just listed. But at the very end of the test, we'll do these 4 steps that you would never do in a full-out failover recovery. And basically these are steps used to clean up the work done from a test recovery and prepare the SRM installation so that it's at full readiness to do a full recovery and respond to any disaster events that might happen. The first of these 4 events is that it's going to power off the recovered virtual machines that had been restored for the test recovery. It will then unregister these recovered virtual machines so that there's no trace of them in Virtual Center at the recovery site. Then it'll prepare itself for full disaster readiness, I guess, so to speak, by re-registering the placeholder VMs for the protected VMs. And then at the very end, it's going to clean up that replicated storage and get rid of the snapshots that had been used for the recovered VMs during the test. This is just to clean up the storage system and clean up the ESX servers on the recovery site. So again, they're ready to handle a full-out failover should the need arise. Now, if you're going to be doing a recovery only, so this would be pushing the big red button, doing a full-out failover to the recovery site. Everything is the same as the both column, except we start off with one very important step, which is shutting down of the protected site virtual machines. Why would you maybe want to do that? Well, this would be a specific disaster case where we have some warning in advance and we have a protected site that's still fully functional, but will be coming under either the risk of being shut down or will be shut down in the very near future. So what we want to do in this instance is shut down the virtual machines so that they can get their data in a known good state. And we'll let the underlying storage software replicate that last known good state of the protected site over to the recovery site. And then we can begin the rest of the recovery. In the case of synchronous replication, or what's another way to refer to basically real-time replication between sites, this is handled very easily by SRM, and that shutting down the virtual machines is really all you need to do to get that storage at a known good state. Now, if you don't have that luxury of synchronous replication and you use what's called asynchronous replication, or replication of your SAN at predetermined intervals, maybe a couple hours or 30 minutes. In the case there, shutting down the virtual machines isn't enough to get the latest and greatest state of those protected virtual machines. What you'd also want to do in addition to shutting down the virtual machines is possibly trigger manually a stored replication to the other site so that you can capture the latest and greatest state of the virtual machines and not have any data loss during the recovery. Now, depending on the schedule, maybe the hurricane is still, a day away and we have all night to do this, you wouldn't necessarily need to do a manual replication. You could just wait until the actual replication schedule happen. Now, you might not have time to do all this within the SRM workflow. So you might actually do this manually or with some scripts. And we could talk about how you might introduce that into SRM later in this lesson. But as a takeaway, it's just good to know that if you have synchronous replication, then this process works as planned. If you have asynchronous replication or replication at predetermined intervals, some further thought and planning might need to be done to guarantee that there's no data loss in an actual failover. So before I demonstrate some of the steps, I'd like to just quickly overview some of the gotchas that can happen with custom recovery plans, or actually with SRM in general. It's good to be aware of the different timeouts that can affect you within SRM. The first one is the command line timeout, which is 300 seconds. And what this is basically doing is if there's command steps entered into the SRM workflow, if they don't finish within 300 seconds, SRM will continue on to the next step and flag them as an error that could be followed up later. Same goes with power state change timeouts. These are 120 seconds. So in the case of a failover, it might attempt to first power down running virtual machines at the protected site. If an answer isn't received within 120 seconds of that virtual machine being powered down, again, SRM would flag that as an error and move on to the next virtual machine. There's also recovery plan response times, which if you are setting up the recovery plan for the first time, you'll note that the default for these is 600 seconds. So for operating system heartbeat and for the time it allows the recovery plan to change network settings. In the case of not having VMware tools installed, you could see that there could be an obvious slowdown here. If you have multiple virtual machines with no VMware tools, that's 10 minutes per virtual machine. And that can add up fairly quick if you're trying to meet a predetermined RTO for some of your applications. RTO, again, being recovery time objective, which is how fast can I boot up and recover my environment. Okay, well, we've learned about custom recovery plan steps, the difference between fault failover and a test recovery plan, and some of the gotchas. But you really need to see this to fully understand it. So let's walk through a demonstration of what the steps look like, how we can change some of the timeouts, and how to add our own commands and messages. Okay, now it's time to go over the recovery steps demonstration. And we're going to cover the concepts that we just introduced about custom recovery plan steps and what our options are to create a flexible recovery plan. But first, let's review the base recovery plan steps that was presented earlier. Again, you'll find us logged in through the vSphere client into the Recovery Site Virtual Center. And the way we got here again was home and site recovery option there, or plugin. And if we look at the site recovery main level of the tree here on the left, you can then easily see that we're logged into the recovery site, since that's the local site, and the paired site is the protected site. So this would be done at the recovery site or your DR location. In order to see the base recovery plan steps, we'll want to select the recovery plan from the tree over here at the left. That brings us to this screen where we'll click on Recovery Steps tab. And what you'll see here is a set of base steps that get created as part of a default recovery plan. As we talked about earlier, not all of these are done if you're doing a test, and not all of them are being done if you're doing an actual failover. So it's good to know what's common to both recovery plans. That basically is steps 2 on down through 8. No matter whether you're doing a test recovery or a actual failover, you're always going to prepare your storage, which, as we talked about earlier, takes that recovered data store, that SAN replicated data store, and presents it to the recovery site ESX servers. The next step is suspension of the non-critical virtual machines. These would be virtual machines such as test and dev virtual machines that you're running at the recovery site to get some value out of that hardware that your company has invested in for DR, rather than just sitting there for tests and actual disasters that hopefully never happen, knock on wood. You could be doing dev and test to get some value out of them. But in the case of a test or an actual failover, you may require those resources to be available to do an actual recovery. So what we do here is suspend those virtual machines in order to save resources. After that, we begin with the actual recovery of the protected virtual machines. These can be arranged in 3 groups. There's a high priority group, a normal priority group, a low priority group, and a no power on group, or a no boot group. Now, the recovery of the high priority virtual machines happens first, obviously. And this could be your domain controllers, critical databases, possibly email. The thing that we pointed out earlier is that these virtual machines will boot up one at a time, regardless of how many ESX servers are in your environment. So be sure to put virtual machines here only if needed, because this can slow down the total time to recover. Once the very last high priority virtual machine is done, which we don't have here, but we can show that later and move some virtual machines there. But once it's done, we'll proceed into the normal priority virtual machines. These can be booted up in parallel on separate ESX servers, although only one virtual machine can be booted at a time on an ESX server. It then proceed to the low priority virtual machines, same rules as normal, and that a virtual machine can be booted up on each ESX server one at a time. No power on virtual machines would finally be registered with your environment and ready for you to do any activities you might need to do to get them ready. Maybe these are virtual machines that can't handle an automatic power on, and you haven't had time to be able to script the recovery of them in order to get them customized for the environment. So these might need some manual touch and feel to get ready to go in your environment. So those are the main steps. I guess it ends up with a message that says test is complete. You can verify when you're done. This is where things diverge a little bit. If we're doing a test, everything so far is described a test setup. But the next couple steps are only done in test and not in failover or the actual recovery. Those steps are the cleanup of the virtual machines post-test, which is number 9 here. What we're doing here is actually removing the virtual machines that had been recovered, removing them from inventory so that you no longer see them when you go back into a normal state. And it's obviously going to power them off before removing them. But that cleans up the inventory so it looks nice and fresh. Once that's done though, it would then, which we don't see here, but would re-register the virtual machines that were the placeholder virtual machines. Again, that placeholder virtual machine is used to notify the site recovery manager that there's virtual machines that are protected and ready to be restored. Those placeholders also store things like custom network settings and other things. That happens only in the test. Same with number 10 here, which is resume non-critical virtual machines. Once you're done doing a test, you'll want to obviously restart up the virtual machines that were running prior. So test and dev virtual machines would then get restarted. These could get technically started up after a true failover, but you don't want that automated in the SRM sense, since they're by design they're non-critical. So we shut them down, or we chose to shut them down earlier. Finally, there is the reset of the storage. So the replicated storage presented a snapshot to the recovery site ESX servers. We no longer want that snapshot presented to the recovery site servers because it's a point in time and we don't necessarily want those virtual machines to continue to be available to be booted from that storage. So what we need to do here is basically take that presented storage and unpresent it from the ESX servers, which would cause a rescan of the ESX box itself so that it sees that there's no more VMFS volumes for the replicated protected volumes. Again, the purpose of that is to prepare the storage for an actual failover and to get rid of snapshots that we no longer need, which can free up resources on your SAN. One thing I neglected to talk about here is when we talk about high priority, low priority virtual machines and how they boot up and how you control which one would boot next or when it would boot, we talked earlier about timeouts within the SRM plan itself. So there's the thing called recovery plan response time, which is looking at things like operating system heartbeat, which is the notification from VMware Tools that it's good to go, or also the change network settings response time. The default for all of these is 600 seconds, and that's controlled by the recovery plan itself, which you can get to by clicking on this top left button, which is Edit Recovery Plan. And we'll click Next until you get to the section called Response Times. This is where you could tweak this if you've done testing and you found out that maybe you could do with a smaller time frame in the case of virtual machines that don't have VMware Tools, and you've tested this and you're reasonably assured that virtual machines are booting in a good time. You don't want to wait 10 minutes for a machine that you know is booting reliably at, let's say, 2 minutes, right? So you'd want to change this down to maybe 300 seconds or 200 seconds. So in addition to the timeouts that we can tweak to help the recovery steps function at the right time, we can add a few things to kind of add some flexibility and do some custom things that you might need in your environment. So the first piece that we can add into a recovery plan is what's called commands, or a command step. It's easy enough to find that. It looks like a little command prompt right here in the middle of this black dark thing with a green triangle. We go ahead and click on that, and actually I might cancel. Let's see where we're at. I'd like to maybe put a command after we've recovered the critical server. Notice we can't do any command steps inside of a priority group, but if I click at the priority group level, my commands are now highlighted. So what I'd like to do is run this right after normal priority. So I'm going to click down below and click command. And what you can do here is anything that can be run from the SRM recovery server at the command line could be entered into this section here. I so happen to have a batch script that I created that we're going to go ahead and put in here. Test critical server recovery.bat. Hopefully we typed that correctly. So as you can see, that inserted an additional step called number 6 here to call the command cscripts test critical server recovery.bat. All this will do is a simple batch script, which I can show you quickly.